Welcome, ladies and gentlemen, to our presentation. We're Team 14, and today we'll be presenting on the coronavirus. Now, I'm sure most of you have heard about the coronavirus, but just as a refresher, it's a novel virus that started in China and has already infected over 100,000 individuals, resulting in over 4,000 deaths, and it's occurred in over 100 different countries. The outline for our presentation today is that we'll be answering three different questions. The first is what happened, and the second question is going to be what's going to happen in the future, and the third is, well, what can we do about it? So starting with this first question, the first thing that we wanted to do was just visualize the spread of the coronavirus. So this is a plot of the cases of the coronavirus across China, and you can see here that the number of cases starts slow and it spreads pretty slowly, but then as the days progress, it explodes exponentially and spreads across all of China, not just the coast. So after we visualized this, we wanted to understand how people reacted. So this is the United States Google Trends data. So this is for the key term coronavirus. As you can see here, the term is highly correlated with both Wuhan and symptom and also SARS. And you can see also there's a sort of an interesting delay, a gap between the first reported case indicated by the blue line and the spike in Google Trends searches. We believe that this is probably due to the Chinese government denying the existence of the virus and not reporting it, and also the delayed reaction in the US media in reporting on the case. Now, one problem with Google Trends data is that they only give us a relative index of search term, not an absolute index. So the big question is, what is the y-axis here? What is this index that we're relative to? Well, the answer is we index relative to the search term Kobe. And that is for Kobe Bryant, the famous basketball player who happened to die around the same time as the virus. And you can see here the spike is about 10 times larger than the search term for coronavirus. So the interest in the death of Kobe Bryant generated significantly more interest than the search term coronavirus. And then we wanted to visualize how the reaction was in Chinese social media. So here's a word cloud of the highest terms on the social platform. And for those of you who don't speak Chinese, we've included the English translations on the sides. Now, there's a couple of these that really stuck out to us, and that was sold out, face mask, alcohol, coronavirus, and medical. We think that these are all here because, well, for example, face mask and alcohol were all sold out. They're both medical. They're both for medical uses, and they were sold out in stores around China around this time. So our next question is, what's going to happen? So we started tackling this by looking at how this compares to other common viruses. So here's a plot of common viruses. We have SARS and Spanish flu and smallpox. And along the x-axis is transmissibility, and that is the ability for the virus to be transmitted from one individual to the other. And along the y-axis is fatality. So the interpretation of this is the further you are along the y-axis, the more deadly the virus, and the further you're along on the x-axis, the faster it'll spread. So you can see here coronavirus is sort of in the middle of the two. It's maybe a little bit worse than the Spanish flu and a little bit better than SARS. And then we wanted to understand exactly how this epidemic was developing. So we applied a very common epidemic model called SEIR, and that splits up individuals into 4 distinct groups: suspected, exposed, infected, and recovered individuals. And we model the exposed as a dependent variable of the suspected, and infected as dependent on the exposed, and recovered as dependent on the infected. And the goal here is to model or approximate the transition probabilities between these 4 states. We took a look at our raw data to start with of the number of confirmed cases over time, and we noticed a bunch of interesting characteristics with this. And the reason why you get such fluctuations is because of actions taken by the government. There's all these actions that the government has taken throughout time, and they have more or less effect on the rate of an infected. 2 of these actions really stuck out to us as very important. And that is Wuhan closed down the city, and they also built a new hospital. So in order to build these two factors into our model, we split up our model into three distinct epochs. That is before any action has been taken, that's after traffic has been shut down, and then after the new hospital has been built. As you can see here, those three distinct epochs are very well represented by our model. This includes this orange line, which looks like it doesn't have all that much variation. However, you can see here, it actually fits that small data extremely well. Now, of course, the really interesting question here is, how is this red line going to develop, right? What is this going to look like in the future? And so here is a plot of our model projected out up to 200 days after day 0, which was the first case. Some things to point out here was it's decreasing rapidly, and there's only about 200 cases in July at day 200. So that's decreasing extremely rapidly. Okay, so now we wanted to move to our third question, and that is, what can we do about it? Well, in order to answer that, we modeled three different scenarios. The first one being if we took no action, the second one being if we simply restricted traffic control, and the third action being building a new hospital and restricting traffic. And as you can see here, doing no action is a terrible outcome. It leads to complete infection of the entirety of Hubei. Restricting traffic does pretty well, and that is leading to about a third of the population becoming infected. However, restricting traffic and building a new hospital does extremely well, with only about 0.1% of the population becoming infected. Okay. In conclusion, what happened? Well, the virus spread quickly and there was a delay in reaction. What's going to happen? The total number of infected people in Hubei will be about 80,000. It's not as bad as SARS, but probably worse than the flu. And what can we do about it? Well, we can limit traffic and not ride on public transit, and we can fund new hospitals. Thank you.